Hello and welcome to Geometry with Mr. Clausen. Today we are going to talk about BPP 8, which is the Energy Contractor activity. And this is kind of a fun activity because I get to play with some Legos today as we talk a little bit about this idea of calculating volume of a specific space, and then we're going to apply some of that concept to determining what type of heating system and that you should use. So what we're going to be doing is looking at volume, how to calculate volume, and to get started with this idea, everything that we've talked about to this given point looks at surface area. So when we take a square footage calculation, we're looking at surface area. And really the concept is pretty simple when we talk about surface area or square footage of something, is we just say, hey, what is the width and what is the length? And so if we say that this is 3 blocks wide and 3 blocks long, we can just say 3 times 3, and that would be 9 square blocks or 9 square inches or 9 square feet, however we're applying it to the given units. And you can see very clearly from a visual perspective that this is how square footage works. You go width times length, and then you get this concept that applies. And whenever we're working with blueprints, it works the exact same way. Now, obviously, these have a little bit of height in that, but this is just a 1 block high example. So if you ever need to calculate square footage of something, this is a relatively basic skill. This is something that can be very valuable to know, but takes a little bit of practice to get the finesse to really get accurate in terms of like some of the blueprints that we look at in this class. Now, some of you it comes very naturally, some of you it might take a little bit, but I know we can all get there. So this is how you calculate square footage, or square inches or anything like that. Square just says it's 2 dimensions, so we can look at a 2-dimensional space. Now, volume is a 3-dimensional space. So you would typically use like cubic inches, cubic feet, and that type of thing. Or if you say a cubic yard, that would be 3 feet by 3 feet by 3 feet. So let's look at an example like that. So if you want to know the volume of something, I have a nice nifty little diagram here where it shows that the volume is the length times the width times the height. Well, we have length and width, but if we go 2 blocks high and we say 3 by 3 by 2 blocks high, well, we understand that we can just take this number according to this formula, go 3 times 3 times 2, and that would give you 9 times 2, which is 18. And again, hopefully this seems relatively intuitive. You look at it, we have 6 blocks here, we have 6 blocks here, and then we have 6 blocks in the middle. And if we decided to take all these apart, you could see that there's 12 blocks there and another 6 blocks there, and that's how you get the 18. So even though I'm showing this example as simple as a situation with blocks, we can get a really comfortable idea of what volume actually is. And we can apply the same thing to something like this. This is let's say each block represents a cubic foot. And if we were to do this is actually what a cubic yard is. If you ever go to a garden center and you get a yard of rock or a yard of dirt, a yard is 3 feet. So if you have a cubic yard, it's 3 feet wide, 3 feet long, and 3 feet tall. So if you were able to build a 3 foot by 3 foot by 3 foot box, you would get a cubic yard. And one of the things that you can kind of think about with this is that if you were to buy a cubic yard of dirt, in bulk and put it into a trailer or back of a pickup truck, you'd have 27 cubic feet of dirt. Now, most of the time, if you want to buy dirt in bags, you get it in 0.75 or 1 cubic foot bags. So you would need to get 27 1 cubic foot bags in order to get the 27 cubic feet that you would normally purchase in bulk at like a garden center in terms of dirt. And so kind of a fun little way to get started with this lesson. So why do I show you that? Well, I show you that because we want to apply the same concept in terms of volume of a house, because you need to understand what the volume of your house is in order to pick an appropriate heating system. Now, you will find generally on the region of the world that you're in that you generally fall into a specific type of heating system. that you would use. And what we typically use is a British thermal unit to kind of quantify a unit of heat. All right, and usually in Minnesota, all right, when I've done the math and I've looked at this, is that you probably should have a heat source that produces about 7 British thermal units for every cubic foot of volume of your house, just as a general average. When I look at the numbers, how well insulated the majority of houses are in, you know, northern Minnesota, and those type of things. So if we go and we look at, you know, this, I've gone out and picked out some different heating systems, and I just went onto the Train website. I got a lot of these numbers from Home Depot. I'm not trying to promote Home Depot or anything like that. They're a great business to buy stuff from, so is Menards and other businesses. But I just kind of picked a website and went through it. But one of the things I wanted to kind of illustrate with this idea, though, is that depending on the size of your floor space can dictate what type of heating unit that you should use. So, for example, if you ever move into an apartment, you'll find that they use a lot of floorboard heaters in those, whereas those kind of cheap, dinky looking things that replace your baseboards and their heaters, I think they're kind of ugly, but they work really well for what they're used for. And if you have an apartment with a relatively low volume space that they occupy, which most apartments are, they work really well. And the other nice thing about electric board heaters is that they just hook up to an electrical meter, and then as a landlord, you just say, hey, you get to pay whatever amount of money that you want to pay to keep your apartment at the temperature that you want to keep your apartment. So it's kind of nice. You don't have to say heat included and then deal with all your tenants going like, like, why can't it be warmer or colder? Like, you can have some control and then pay for the electrical cost associated with that. Now, if you live in warmer climates, you know, let's say you go to Texas or California, you'll see heat pumps used a lot more frequently. And if you ever seen a heat pump, it's really just, it looks like an air conditioner. And actually, air conditioners are heat pumps. It's just, you can actually reverse them if you so choose. And they produce about 36,000 BTUs of heat, or they can pull out about that much as well, and just by reversing the process. And these will be able to go and heat a little bit more floor space. And, you know, generally you can have more than one of these heat pumps kind of hooked in series if you need a little bit more from, you know, a heat source. What I will say is that, you know, you're going to notice that there's a little bit of overlap. I made sure that I covered every, you know, temperature range here. So if you know, have a volume of something that's like 7,400 square feet, you could technically use the baseboards or the heat pump, at least according to my system. And again, these aren't, you know, perfect. You could use some of these in conjunction with each other, you know, and if you're looking at these different furnaces, you know, or heat sources, there's no reason you are limited to just one, or if you want to go a little overboard or overshoot a little bit, there's nothing technically wrong with that. But for this activity, these are the volume ranges that I want you to use. So if you measure a floor plan and it's 7,400 square feet, I want you to say system 1 or system 2. All right, just as an example. Now, I have some Train furnaces here. I just went onto the Train website and I just looked at a bunch of different furnaces. And generally, furnaces range, you know, from about 72,000 BTUs, and they go up to about 120,000 BTUs. And you know, and with most of these furnaces, they're really efficient now. Some of them are, you know, 95 to 98% efficient, maybe even a little higher if you're willing to spend a little bit more money on these furnaces. You know, these are 95% furnaces. I think the furnace I have in my house is an 80% furnace. It works just fine. But when we're looking at some of these different furnaces and the BTUs that are there, generally based on the calculations that I've done in looking at this activity, is that, hey, if you have 72,000 BTUs, right, if we're averaging about 7 BTUs per cubic foot, well, this is about the range of volume that you're looking at that you should, you know, produce with those number of BTUs. Now, the reason that's a little under 10,000 if we're averaging the 7,000 BTUs per square foot is that this is an 80% furnace, so you're not getting every single one of those BTUs when we're doing the calculation. So that's why you may see the volumes kind of sway a little bit like that. But this will give you a range of different options and kind of what size furnace that I think you should consider implementing. Like you'll see that these are both 96,000 BTU furnaces, but since this is a 95% furnace and this is an 80% furnace, you'll see that the 95% furnace will put out more heat in general, and therefore I am estimating that they can cover more cubic footage. Now, again, there's also in-floor heating options. There's geothermal heating options where you actually like bury tubing in the earth, and if you are willing to fork out that money, where you have radiant heating systems where you bury like water lines like 30-40 feet into the earth and use like the natural heat of the earth to either keep your lines cool in the summer or heat your lines up during the winter. Those are ways to kind of supplement this, but we want to just keep it to one heating system per house. So what do I want you to do in terms of this activity? Well, what I want you to do is I want you to calculate the square footage of a set of plans. Now, if you did BPP 7, I want you to do all the blueprints that you did for BPP 7. So, for example, everyone did floor plan 1, and then you should also have the floor plans for your other things. Now, if you worked in groups on that project, I'll have you do all of them, but if for some reason you weren't here or we didn't have this lesson in school, you'll just do the ones that you were assigned outside of class. So I will require everyone to do cabin 1, cabin 2, plan 1, and then the other plans associated with BPP 7, whether you were person A, B, C, or D, for example. All right. So I don't have the physical worksheet, but this is BPP 7, the worksheet that you would have done in the previous activity. And so, for example, if you were person A, you would do cabin 1, cabin 2, plan 1, and then 2, 4, 6, 8. If you were assigned as person B, you would do cabin 1, cabin 2, plan 1, 5, 6, 7, 9, and so on and so forth in terms of the examples that you did. And like I said, if you worked on these as a group in class and you were working together on that, you'll have all 10 plans. So you can just go and calculate all these, because these are really quick calculations when we're going and we're assuming all of this. And so I'm going to work through plan 1. This is what we just worked on in BPP 7. Now remember, I actually calculated that wrong incorrectly, and I put a little note in my video saying that I did that incorrectly, but you should have all these numbers. This will be a very fast activity. If you've kept all your other blueprints to this point, this will be a very quick activity. And so if plan 1 is 1,039 square feet, or feet square, what you're going to do to calculate volume is you are going to multiply this by a height of 8, sort of like what you did for BPP 3, because the majority of houses have this headspace of 8 feet when you're going and you're doing these calculations. So we'll just take all of these numbers, we'll multiply it by 8 feet as the height, and what you'll notice is that you'll go 8 times this number. So let's pull out a handy dandy calculator here and go 1,039 times 8, and you'll find that the volume of this is 8,312. Now this is really important. I want you to indicate units correctly as we're going through this project. I think this is a very important skill to be keeping track of. And the units here will be the feet squared times the feet. So feet squared times feet will be feet cubed. And that'll be what I want you to write down. Now if you get feet cubed, I want you to go look at that, and it's like, if this was your floor plan, with that square footage, what heating system option would be within the range that we're looking at? Well, I just want you to look at the range of numbers, and I want you to go, 8,312 is in between those two values, so we will use heating system 2. And like I said, if it was like 8,400, 8,600, you could choose between these two systems, and you can just either write one of the two down, or if you wanted to do 2 and 3, if it was that case, you can totally do that. So that's really all I want you to do. This will be a 15-point assignment where your grade will be based on the interior square footage calculations within 10% of the 12 floor plans. So if you haven't talked to your peers and confirmed any of those numbers, go ahead and do that. Make sure that you know, things look solid. Determine the volume of each of those homes based on the square footage calculations, assuming 8-foot high walls, which you'll read on the the front side of this page. And then selecting the appropriate heating system listed based on your volume calculation. So these things are broken up a little differently. So what I mean by this last part is that, you know, if all your volume calculations were off, but you picked the right heating system anyway, you'd still get those 5 points. Okay. So with that said, you know, if you worked on this by yourself to this point and you haven't been able to work with a peer, just do the floor plans that you were assigned for BPP 7. And if you've been working at it as a group, do the whole thing. So with that said, I hope that you got a basic idea of how to do volume calculations and learned a little bit about heating systems and cubic volumes. And with that said, let's do some math.